everybody, my name is Alec Gipp, and today is our first Kids Are Scientists Do virtual lesson, or KAST, and today we're going to be talking about batteries. So, every KAST lesson revolves around an experiment or two, and so today this lesson revolves around my car remote. But what's the problem? My car remote won't work. So today I went to the supermarket and I tried to unlock my car, and nothing would happen. So I kept on trying, and eventually it worked. And I have a feeling that might be due to my battery. How do I know? My car is made in 2003, and my battery as well is from 2003. So I looked on the specifications, and they say your battery should be replaced every 5 years. Well, 5 versus 17 years, it might be the battery. But what will I do? So I'm gonna go ahead and test the battery, see if it can actually power my remote. But first and foremost, let's go ahead and learn some terminologies. So again, I'm going to test it. And so we're going to cover these terminologies in this video. A battery, charge, voltage, terminals, and the remote. These are all things you've probably heard of before, and we're going to go in depth what they do and how they affect the battery. And one of the most important things for this video is that no math is required. You do not need to know any bit of math. The equations for a battery can be quite complex, and so maybe the equation will be unwieldy for you all. So we're going to omit them from this video. So what is a battery? And sometimes you hear this term, my battery won't hold a charge, or it's leaking a lot of charge. But what is charge really? So we first know that charge can be positive or negative, or even zero at that point. So charge is a very fundamental property of particles, and so I can't really explain now what exactly charge is, but know that charge is a property that physicists have determined that all particles have. Particles can either have a positive, negative, or zero charge to them, and they can have a certain amount of positive. They can have, say, 23 coulombs positive charge. They have negative 46 coulombs negative charge, or they can have 0 coulombs charge. So, and that's what charge is. It's just a property of these particles, or any single element in the universe. So, a battery is an electromechanical device, say that 3 times fast, that makes charge. Keyword, makes charge. It does not hold charge. So we have a different device, an electrical device that holds charge, and we call that a capacitor, if you have heard that before. But when people say that my battery does not hold charge, well, that doesn't really have any merit to it, because a battery, all it does is make charges. So how does it make a charge? So if you go to Duracell, you go to a Duracell commercial, you'll see that we have a new lithium-ion compound in our battery. So lithium-ion will be in these batteries. And so what they do is, say this battery right here, this small battery, and you can see it, that there's lithium ion inside, and the particles there, they interact with each other to create this charge. And so there's this constant interaction between particles. And over time, what happens is that the interactions between these particles kind of slows down, and so they don't make enough charge. And so that's one of the reasons why we have battery failure, is that these reactions do slow down. Eventually, they can come to a halt. So, and that's what a battery is. And so here's the last term, voltage. What is voltage? You see every battery is rated with a voltage. What is it? And I don't know if you can see where my cursor is, but these are power lines. So you'll see them mostly where you are, especially if you live in the suburbs. You don't really see these in cities. You see these different kind of variants, but these are power lines. And what they do is, and if you go up to these power lines, and you'll see a sign that says danger, high voltage. But what is voltage? And this is a very confusing term to most people, and hopefully I can clear that up. And is voltage energy? Well, it is not actually. Voltage is not energy. So if voltage isn't energy, then what is it? So we define voltage, we define this measurement called voltage as the energy per charge. So what do I mean by that? So we know that particles have a charge to them, like positive, negative, 0, and you can have any certain amount of positive or a certain amount of negative or 0 charge to them, right? And so let's take an example here. if we know what an electron is is a electron is a very, very small particle, right? The mass is very small, not negative, 9.33 times 10 to the negative 31 kilograms, something like that. Very, very small. And so the radius of an electron is very, very small. You can't really see it. You need an electron microscope to actually view an electron. But let's just say we have these particles, electrons, and we have a lot of them. And they have a certain charge to them. And if we have a certain amount of electrons there, they have a total charge to them. And that total charge can equate to how much energy they can give off. And so voltage is how much energy can these charges give off per unit charge there is. And so we say that this is the potential, right? How much energy could they give off? So, and next, so that's really it for voltage. And let's move on to what our mode is. So if you see this schematic on the bottom here, we're not going to go into how this operates. This is a very the operation of these kind of circuits are relatively complex, and I won't cover them in this video. But I don't know if you can see where my cursor is. On the top left, you'll see a short bar followed by a long bar, followed by another shorter bar, followed by a longer bar. And in all circuit schematics, universally, what that means is that's where a battery goes, right? So the battery, what it does is it is connected to the circuit, and this battery, what it does is it produces a certain charge, and that feeds the rest of the circuit, right? So the rest of the circuit operates off of this battery, right? There are transistors, resistors, and it looks like an IC here too. So again, things you really won't really need to know, but it is nice to see kind of schematics anyway. So, and whereas the voltage from this battery to operate. So if we're going to go ahead, and I opened up my car remote while we were talking, and that this circuit schematic is the same one for here. It's just there. Can you see it? You can see this kind of blocky part match up with this part right here, but that's about it. Can't see much. And so what we call this is a PCB. Where this green thing here is called a PCB, or we call a printed circuit board. So printed circuit boards have allowed us to get devices on a really small device on a really small platform, so we can hold in our pocket. So let's just say back in 40 years ago, we could not have this circuit in our pocket. Let's say we probably need like the size of a book to hold a circuit. Now we can have it just in our pockets. This is great to know. Okay. So, and now that we covered all the terminology needed for this lesson, how am I going to test the battery? Well, we use a voltmeter, right? So the battery is determined by the voltage. And there are certain other factors, there's some other qualities you can know, but for these small batteries, we generally talk about voltage. So again, current, charge and energy are related to voltage, which is the main descriptor of batteries. So we use something called a voltmeter, or in the most general case, we have a multimeter. So when we say voltmeter and multimeter, we kind of think they're the same thing, but they're not really. Most people in your household today, especially your parents or other ones, they'll have something called a multimeter, which is that picture on the right here, this orange one, and what's in my hand right now is a multimeter. These are different measurements as aside from voltage. They can measure resistance, they can measure current. This one can even measure temperature. So that's what a multimeter does. It has different functions. So, and we're gonna place this multimeter across the terminal. So we have a black wire and a red wire across the terminal. So you hear this phrase a lot that says, okay, we're going to measure across the terminal. So what are terminals? So I don't know if you remember what I said maybe a minute ago, was that we say that voltage is how much energy could these charges give off. And so we call that a potential. So let's use a couple analogies here. I say this toy car. This toy car is 1 inch longer. And so you might think, okay, 1 inch longer than what? We say this pen. This pen is 23 grams heavier. 23 grams heavier than what? We always have to have a metric or a basis to have our measurements off of. So it'd be correct for me to say this toy car is 1 inch longer than this toy minifigure. this pen is 23 grams heavier than this car battery. So we have to have that basis here. And so when we say that this battery is 12 volts compared to what? So we always have two measurements. We always have two sides of the battery. I don't know if you can see here. I took out the battery already. So we see, I don't know if you can see it. It's kind of hard to see. See a plus, hopefully you can see that, and a minus. I should be mentioning here, this is not the sort of battery you see every day. Most of the batteries you see are cylindrical, and we call them AA or AAA batteries, or even quadruple A. And that's just a standard for how we kind of compact the battery. And the operation for all batteries are the same. They produce a DC voltage. So we have a positive here on this kind of shiny part, and we don't have anything marked on the back. They're both shiny, kind of hard to see. That's the backing side. So when we see the positive, we say that this positive side is 12 volts higher than the other side, the negative side. So that's how we measure voltage. And if you talk to someone older, right, they'll say that they'll talk about batteries and say, what's the potential difference of this? And you might think, what's the potential difference? Well, that's what we mean, the difference between the top terminal with respect to the bottom terminal. So potential difference and voltage are the same thing. Voltage is potential difference is voltage. It's just terminology. Especially if you're in physics or engineering, we use potential difference. If you're in just general consumer, you'll say voltage a lot. So we're going to go ahead and use our multimeter and place on DC voltage. So you have to talk to your parents or whoever you're with, guiding the experiment how to use multimeter. We're going to be using DC volts for this. And I don't know if you can see, you probably can't, but it says I'm at 2.2 volts. Given that my car battery operates at 3 volts, it probably won't cut it. So I looked up the specifications, and the lowest my car battery will operate on is 2.8 volts. And I'm at 2.2 volts, so that won't cut it, unfortunately. So I went ahead and I got a new battery. Let's go ahead and test it. And lo and behold, whoops, it says 3 volts on it. So let's go ahead and put it back in my car remote. And I should say that these car remotes are very expensive. They can be a couple $100s each. So please use guidance when working with these, because I wouldn't want anyone to break these. So hopefully, and thank you for coming. That concludes our experiment. And I hope you all learned today what a battery was, what voltage is, what charge is, what the and the certain kind of terminology that get mixed up here and there. And while this wasn't a tutorial to replace a car battery per se, it was to show you the basis behind the operation. So thank you for coming. The website here we have is www.kast.org. And if you want to email me about these videos or about certain content, you can email me at alec.yip@kast.org. And actually, I almost forgot something for this experiment. That if we have this experiment, we always have to test. Right? We have to test if this works. I tested the voltage of the battery, and I can perform other tests on the circuit to see if they work, if it's getting the required voltage. But that's kind of complicated and takes a lot of time. But you know what the easiest way is? I just go outside and test out my car, see if it works. So while I go do that, you all have a great day, and see you in the next video.